Hello. Today's lesson is going to be broken into a couple of different videos. And the first one, we're going to work on simplifying expressions with radicals and with rational exponents. So most of you were okay with finding the square root of a number, but I had some questions about finding something like the fourth root of a number. So this process is really similar to when we're finding the square root of something. The first step is that we're going to factor the radicand. So remember, the radicand is the number that's underneath the radical symbol. So in this case, we're factoring 256. And I'm going to break it down into its factors. First, I start with 2 times 128, and then I know that 128 is 2 times 64. And then right away from 64, I'm actually going to break that down. I know that that's 8 times 8. So I did 2 times 2 times 2, which is 8, and 2 times 2 times 2, which is 8. I broke this all the way down into its prime factors. You don't have to do that if you see earlier that you could group them in some way. But I'm looking for groups of 4. So my second step is that I'm going to look for groups of 4 or whatever other root that I'm using. Let me move that over so you can see what I've already written. So because I'm finding the fourth root, I'm looking for a group of 4 right here, and then I've got another group of 4 right here. So I can take a 2 from this group out of the radicand, and I can take a 2 from that group out. So what ends up being outside of the radicand is 2 times 2, and there's nothing left to go inside of it. So my answer to this problem, which I never even wrote anywhere, is 4. Again, it's the 2 from the first group and the 2 from the second group. So that's a pretty straightforward one. The next thing that was on your mid-year review that some of you had questions about was what happens when I have something like this. So my it doesn't look like it's in a radical, but it has that rational exponent, so that exponent that's a fraction. So remember that I can rewrite that in radical form, and whatever is in the denominator, so I'm going to change the color of my highlight here, whatever is in this denominator is going to be that root. So I'm finding the 7th root of 256. I used 256 in my first example, so I'm not going to break that down into its prime factors again, but I know that it was this many 2's, and because I'm finding the 7th root, here, I'm looking for a group of 7, so I have a group of 7 right there. So 2 is going to come out of the house from that group, but this 2 right here has to stay inside. So that 2 stays inside the house. The other 2 comes outside of the house. So hopefully that will help with some of those basic simplifying radical expressions. I realize right now that when I made my notes for this, I didn't show you one thing that's important. So I'm going to add on right here, rather than redoing my whole video, and just remind you that if I had something like 25 to the 3/4 root, I'm going to highlight in different colors here. I'm first going to take the 4th root of 25. Actually, I'm going to change the problem. And again, I could stop right now and I would have to re-record everything that I've done. So bear with me as I fix my problem. I'll get better and better at this, but at the moment I don't want to re-record. So I'm going to make this 3/2, which is what I meant to do in the first place. So the first thing is that I'm going to find the square root. So keep in mind that this is actually looks like, if I just focus on that part, it would be 25 to the 1/2. And so that's the same thing as the square root of 25, which we know is 5. So I've taken care of the square root part, but then that 5 is still being raised to the third power. So that third power, I'll change the color of my highlighting. Oops, that did not change the color of my highlighting. How about that? That numerator is going to be what I'm raising the power to. So this is going to be 125. So the denominator is the root that you take, and I would make it small first, and then the numerator is the power that you raised it to, which is going to make your number bigger. Next, we're going to look at simplifying expressions with more than one term, and these are the problems that were on the top part of the page 2 in your review guide. So it's something like this problem, 6 plus the square root of 44 over 2. So our first step is that we're going to simplify the radical. So again, this is the radical, so we're simplifying that part of it. And that simplifies to 2 times the square root of 11. Basically, I know that 44 is 4 times 11, square root of 4 is 2, and 11 stays in the house. So I think most of you are okay with finding the square root of something like that. So then I'm left with 6 plus 2 times the square root of 11 all over 2. And then I want to reduce. So when I'm reducing, I'm looking at what can I reduce this by that's the same, that will end up with the same denominator as this. So I want to keep them with a common denominator, but I want to reduce them if I can. So 6 over 2 reduces to 3 over 1. 2 over 2 reduces to 1 over 1. So I'm going to rewrite it as 3 plus 1 times the square root of 11. A little bit more difficult problem is this one, where I have negative 4 plus the square root of 32 all over negative 2 times 5. Well, first of all, I'm just going to simplify negative 2 times 5 to be negative 10. And then I want to simplify this radical. So the square root of 32 simplifies to 4 times the square root of 2. And then I'm going to look to see if I have any, if I can reduce this, and if I can reduce this, keeping the same denominator. So when I have a negative 4 divided by negative 10, usually I want that leading term to be positive. This is not absolutely required, but it makes the old dead guys happy if we make that leading term a positive number. So a negative divided by a negative is going to be a positive. 4 over 10 is going to be reduced to 2 over 5. And then this 4 over negative 10 reduces to, I'm going to move the negative up here because 4 over negative 10 is going to be negative 2 over 5. So that reduces there. And then my square root of 2 is left in the house. Alternatively, I cannot, if messing with the negatives is confusing to you, so this is better. This is okay if I do the same reducing, but I don't get rid of if I just leave the negatives alone. So I'm going to have negative 2 over negative 5, reducing my first set, and then I'm going to have minus 2 times the square root of 2. I'm just going to double check. This actually should be a plus, because I'm just keeping the signs of everything the same. So either of those is okay.